I'm going to show you how you would go from your part in your design software to having a finished cut file ready for the machine to process. So here I am starting with my part in SolidWorks. I'm going to go ahead and open up just that top gear section. So here I have just this top gear, and the first step will be going to save as, and then we're going to make sure to save this as a DXF. So VCarve, the software that we're going to be doing our tool pathing in, that can accept DXF, DWG, and PDF files. So in this case, we'll have it saved as a DXF. And once that's saved, we can import that DXF into VCarve. So on the left-hand side here, you can make any edits to the file that you may need, but we're going to go right ahead to the tool pathing. So on the tool pathing end here, we have all these different types of operations. And again, I'm not going to go into the details of what each one does now, but you have full control over your feeds, speeds, tooling. All of that information would be held in this section here. So I'm going to check on my tool paths. Looks like everything there is correct. So the last thing we would do is save this as an NC file. So I'm going to go to save. I check to make sure that all of the tool paths are selected, which they are, and then I would save tool path. And again, so this is going to save as now an NC file. And this NC file contains all the G code that the machine is going to read. So once my NC file is saved, I need to now load the NC file onto the router. So I'll come into my A2MC app manager and select my file manager. Now to open up file manager, it's going to ask you to put in the IP of the machine. And once you've connected to the table, you'll be shown a screen like this. So you're going to go ahead, find where you saved your file. In my case, I have it saved down here. I'm going to select the file that I want to move over to the machine, and I'm going to hit this green button to now load it onto the table. Once that file is loaded onto the table, you can either head over to the machine and select the file directly from the Smart Console, or if you're at your computer still, you can right-click and hit select, and now this file is ready to go and cut.
Hey guys, before we begin our cutting today, I'm going to give a quick overview of the machine we have in front of us. So this particular machine is an Infinite 4010. The 4010 stands for the bed size. That's going to be a 5-foot by 10-foot long process area. Moving up to the carriage of the machine, we have our Hsd Spindle, and that Hsd Spindle is working in conjunction with our 10-position tool changer. Coming back to the spindle again, you can see our dust collection boot we have. This is our high-capacity dust collection. Attached to that, we have our bellows seal, and that creates a nice tight seal for that dust collection boot to get the best possible vacuum. On this one, when we're cutting plastics, we're also going to be using our cold air gun. What that cold air gun does is keep a nice cool breeze blowing over the tool and the material to help keep those temperatures down. On the front of the machine, you can see one of our pins here. So we have 3 different pop-up pins, and those are going to retract when the job starts and then pop back up once the job's finished. That makes material location very simple on the machine. As well, the entire machine is a vacuum bed with different configurable zones. The last thing to mention is the machine is servo-driven with helical racks. Now that we've gone over the overview of the machine, we're going to move on to the cutting process next.
So here we are now beginning the cutting process. As you can see, I have 1-inch thick PVC on the table, and we'll be cutting that using the Berlin 13592 cutting tool. Now this tool is a 3/8 O-flute upcut tool. The O-flute really helps in this situation because you get the most or the best possible chip evacuation with a single flute. That becomes very important when cutting thicker materials such as this 1-inch PVC, because one of the big issues with cutting plastics is chip rewelding. So the better we can get the chips out of the cut, the less chance we have for the chips to re-weld. Another thing you'll notice is on these 2 smaller size holes, we cut them in 2 separate ways. So for the very small holes, we went ahead and actually pocketed out the entire piece of material there. On the larger sized holes, we just did the perimeter cut, but because those pieces are still too small for the vacuum table to hold, we left on little tabs that can easily be broken off and cut near the end of the process. So again, with this tool I'm running at 175 inches per minute, and it's blasting through this PVC in 3 passes. For the next cut, we're cutting 1/2 inch UHMW. Now, similar to with the PVC, both the tools I'm using with the UHMW are going to be O-flute upcut tools. Again, when cutting plastics, we're just trying to get the chips out of there as best as we can. So for cutting these small holes, I'm using a 3/16 bit, an Untitled 65-018. Now this bit for plunging these holes, we're actually doing a slight circular interpolation. It's always best practice when using end mills to not plunge straight down if possible. So we do a slight helical motion, and that just helps reduce some of the load on the tool. You can see at this point we're doing a tool change, and next I'll be switching to a 3/8 bit, again from Untitled, the 63783. Now this tool again, it's designed specifically for cutting plastics, and it gives us the best chip evacuation possible. This bit for doing the profiling, we're running at 350 inches per minute, and it's cutting through the material in a single pass.
Hey guys, so we just finished the cutting process, and here I am with our assembled pieces. As you can see, this first one here is our UHMW part, and that's part of a bottling assembly line. The other piece here we have is our PVC bore spacer, and that's used to space out our conduit. So we're getting a closer look at these pieces. You can see they have a nice, smooth, consistent finish, and that can be attributed to a number of different things about the machine. Our servo motors and helical racks, as well as our great dust collection boot and bellow seal. So again, both these pieces today were cut on the Infinite Router system, and I'm going to go ahead and toss over to our Q&A session.